Hello, I welcome you all. The problem reads, neglecting the size of the ball, determine the magnitude VA of the basket ball's initial velocity and this velocity when it passes through the basket. This problem is coming from the Engineering Mechanics Dynamics 14th edition by RC Hibbeler. So just remind ourselves of the equations that we're going to employ. We have velocity which is a time derivative of position. We have acceleration, which is the time, position, or velocity, and I derived the equation from the two, making it subject to the formula. And then from the three equations, we are able to derive three more, given that acceleration is constant, and t is equal to 0. Okay, then we have S naught and B naught. These are the boundary conditions. Then the derived equations for these conditions become S equal to S naught plus V naught T half AC T squared, B final equal to V naught plus ACT V squared equal to V naught squared plus 2AC S minus S naught. Right, so here we have somebody throwing a ball. We've been asked to find the initial velocity as well as the velocity when it passes through the basket. To just increase, we can also want to find the maximum, which is not part of the questions. Let's say we also want to find the maximum somewhere there. Let's say we want to find the maximum height. All right, just for curiosity's sake. All right, so let's say we also wanted to find the maximum height. It's not part of the problem. So max height that the ball will reach. Okay, right, so let's label this. Let's say we're going to be dealing with horizontal in this particular problem and vertical motion. So for the horizontal motion, we do not experience any acceleration, but for the vertical motion, it will experience acceleration. So let's say at B here we have also this velocity, which will also have some components, one in this direction like so, and the other one in that direction like so. Okay, so let's label them. So let's say this one is VAY, which is equal to VA sine 30. Okay, sine 30. Let's say we do have another angle there. We have an angle here that we're just calling theta. Okay, of course this one is 30, this one is 30 degrees, and then we have this one VAX, which is equal to VA cos 30, and let's call this one as our VBX, which we are going to show is equal to VBX, okay, VAX rather, and then this one is VBY. Okay, let's call this one as our VB, as our VB. Okay, right, of course we are not finding the theta unless otherwise. Right, so we have all this information. Our reference is going to be this point. Let's call it as our reference. This is our reference. So this one here is our reference. Okay, a reference point, a reference. Right. So with this, let's start with the horizontal motion. So we say horizontal motion. So like we said, horizontal motion, we're not experiencing any acceleration, and we're going to go with this equation, right? We are going to use this equation. For now, we'll have two equations that will solve simultaneously for us to find VA. So let's write this. So we have S equal to S naught plus V naught T plus half acceleration. We are saying is constant, but of course along the horizontal it's going to be equal to 0. So we have S itself, which is the range is 10. S naught is equal to 0. Okay. V naught in our case is equal to VAX, right, which is equal to VA cos 30, and then our AC in that case is going to be equal to 0. Therefore this part is all 0. Okay, and also this part of course is 0. We don't have that, and our equation becomes 10 equal to V naught, which is just VA cos 30, okay, times T. So we have one equation. This is one equation. Let's go to the next. So let's call vertical motion. Vertical motion, we're using the same equation. We just change the values. So we have ACT squared. So here we have S, which is equal to the final is a 3. We have S naught is equal to 2, and then we have B naught is equal to VA Y, which is equal to V sine 30, V sine 30, VA sine 30, VA sine 30, okay, and then we have, what else do we have? Of course our AC here is available, it's a minus 9.81 meters per second square. So if we are to plug in all this information, then we're going to have a 3 is equal to 2 plus VA sine 30 times T minus half by 9.81 by T squared. So we have two equations. From this, I'm going to make T subject to a formula. I'll make VA subject to a formula. I'll say my VA is going to be equal to 10 divided by T cos 30. And then I'll get this part. I'll get this part and plug it there, here. And once I do so, then I'm going to have the following. I'm going to have 3 is equal to 2 plus a VA there, it is 10 divided by T cos 30 sine 30, then times T minus, this is 4.905 T squared, right? Half of that, 9.81 by 0.5, 4.905. Of course, this and this cancels. Then what do we have? Let me bring this the other side. I'll have 4.95 T squared equal to equal to 10 10 tan 30, right, plus 2 minus 3. Therefore our t, plus or minus, but we are just interested in the positive value. I would have said plus or minus, and we're just interested in the positive value. We don't have negative time. So we have 10 tan 30 plus 2 minus 3 divided by 4.905, and square root of that. I'll round it off to 2 decimal places. Okay, so I'll say seconds. So this is the time it takes for the ball. It's the same. It's the time it takes for the ball to reach B. Okay, so once we found this time, we can go ahead and calculate. There. Let me bring it here like so. Then I come like this, so that I reserve my space. Okay, so let's now calculate the VA. So I'll use this equation here. Okay, so we said 10 is equal to VA cos 30 times T, and therefore our T is just going to be equal to 10 divided by 1 VA here. VA is equal to 10, right? 10 divided by T cos 30, and our T is equal to 0.99 seconds. Therefore VA will be equal to so we have 10 we are plugging in T here, we plug in T here. Okay, VA is going to be equal to 0.99 cos 30. This gives us 11 because of rounding off. Okay, so this gives us 11.66 meters per second. Alright, we have found this value. Let me just prove this. Okay, so we know that let's check this, just this. We know that this condition, so let me use this equation here in the horizontal direction. So we know that VB, let me just move this a little bit so that we reserve some space. Okay, so we know that V that is in the X, VA VBX is equal to V naught, which is going to be equal to VAX, and then plus this ACT, and this part is 0. Therefore VBX is equal to VAX, which is equal to VA cos 30. Alright, so I just wanted to talk about this. Let me just put it in a small box like so. Okay, so since we know this, therefore we don't have VAX. Let's go to VAY. VBY, we need to find this. So let's use the same equation. Let's find I'll say VBY using V equal to V naught plus ACT. Alright, so say VBY is equal to VAY then minus 9.81 then by T, which is a 0. So VBO, this one is just a VA, which you already know. It is 11.66 sine 30 minus 9.81 then times 0.99. Therefore, our VBY is just going to be equal to VBY is equal to that's 11.66 sine 30 minus 9.81 by 0.99. So this one we get minus 3.88 meters per second. Alright, and then we also know that our VBX is just equal to 11.66 by cos 30, and this is equal to 11.66 cos 30, and this is equal to, okay, we'll leave it like this so that we don't round it off so much. Alright, so we know what this is. Therefore, VB will just be equal to square root of VBX squared plus VBY squared. Let's find VB. 11.66 cos 30, okay, squared plus 3.88 squared, square root of that. So we have VB equal to 10.82 meters per second. Right. So let's find max height using V squared equal to V naught squared plus 2A S minus S naught. So we know that at this point we have the velocity like so, and then let's say we have another component like so. So we know that if we label this as just Vy will be equal to 0, while Vx will be equal to Vax. Okay, so this becomes 0 equal to 11.66 sine 30 squared minus 2 by 9.81. Our S is what we want to find, so just say H. Then our S naught is 2. Okay, so making h subject to the formula. So h, which is equal to max height, will be equal to, making it subject formula, this becomes equal to 11.66 sine 30 squared. Then we have what do we have? Then we divide this by, divided by 2 by 9.81. Okay, and then plus 2. Right, so we have a 3.73 meters. Okay, let's check it out again. 11.66 sine 30 squared divided by 2 by 9.81 and plus 2, 3.73. So this maximum height is 3.73 meters. Alright, I think this is about it. Let's outline the solutions. We calculated the initial velocity that we have been asked, which is VA, and this is the value here. Okay, again the value is like this because we had to round off the time. And then we also calculated the initial velocity VB, which is this one here, when the ball goes through the basket. Then we decided also to just calculate the height, which was not part and parcel of the problem. So I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screencast.